Hi, I'm Kathy Levinger. In this lesson we're going to look at graphs and equations of lines. Let's start with the definition of something called slope-intercept form. For a linear function, f of x equals ax plus b, the slope of the line is a, notice that's the coefficient of the independent variable, and the vertical intercept is 0b, b is this constant. This form of the equation is called the slope-intercept form. Well, let's try it out and work some examples. What we want to do here is write each linear function in slope-intercept form. Then we want to identify or find the slope and vertical intercept. The first equation is 6x plus 3y equals 12, and we're told that y is the dependent variable. In order to have slope-intercept form, we need to solve for y. So I'll start by subtracting 6x from each side of the equation, and I'll get 3y is negative 6x plus 12. To finish solving for y, I now want to divide each part of the equation by 3, and that gives me y equals negative 2x plus 4. I've got slope-intercept form. The slope represented by the letter a is negative 2. The vertical intercept is the ordered pair 0, 4. Well, here's another linear function. f of x, remember, corresponds to y. So we already have y by itself, but we need to clean up the right-hand side, starting with distributing negative 3 through the parentheses, in which case we get 2x minus 3x plus 21, plus because we had negative 3 times negative 7. Then combining the like terms, we'll have f of x equals negative x plus 21. Negative x is 2x minus 3x. And I have slope-intercept form. The slope is the coefficient of x, which is negative 1, and the vertical intercept, written as an ordered pair, is 0, 21. Our last equation is 4x minus 7y equals negative 2x plus 3. Again, we're told y is the dependent variable, so we want to get y by itself. As a first step, I'm going to subtract 4x from each side of the equation, which will give me negative 7y equals negative 6x plus 3. To get y by itself, I'm now going to divide everything by negative 7, each part of the equation by negative 7, which will give me y equals positive 6 over 7x minus 3 over 7. The slope is the coefficient of x, which is 6/7, and the vertical intercept is the ordered pair 0, negative 3/7. Let's try another example. Here's what we want to do. We want to graph this time a function using its slope and vertical intercept, and then we're going to check our graph using a graphing calculator. And the function that we're going to graph is f of x equals negative 2x plus 3. It's in slope-intercept form. The slope of the line is negative 2. The vertical intercept is 0, 3. Back to the slope for a minute. Remember that we can consider the slope a vertical change over a horizontal change. So I'm going to write negative 2 over 1 so that I can see a vertical change and a horizontal change. And now I'm ready to draw a graph. So I'm going to draw a coordinate system. Y-axis, x-axis. Start by locating your vertical intercept at 3 and put a point there. From there, count out the slope by using the vertical change over the horizontal change. This vertical change is down 2, and the horizontal change is to the right 1. Then we might want to carry that out again, so I'll go down another 2 to the right 1 and ignore that point. And I'm ready to draw the equation of the line through these points. Now I want to check that using my graphing calculator. So let's go to the calculator and push y equals to get in graphing mode and enter negative 2x plus 3. Let's check what window we have set, and we have a standard window, so I'll push graph, and that looks very much like the line that I graphed by hand. Let's try another. This time we want to graph the following function using the slope and vertical intercept and check our graph using our graphing calculator just as before. The equation that we're working on is 2p plus 6q equals 5p minus 6. Q is the dependent variable, so q is what we want to isolate on the left-hand side. Start by subtracting 2p. 6q equals 3p minus 6. Now divide by 6 every part of the equation and simplify to get q equals 3 over 6 is 1/2 p minus 6 over 6, which is 1. I've got slope-intercept form. The slope is 1 over 2, vertical change 1, horizontal change 2. The vertical intercept is the ordered pair 0, negative 1. So I'm going to draw a coordinate system. And this time I'll label my axes P and Q to correspond to the variables in my equation. Start by locating the vertical intercept at negative 1 on the Q axis, and then from there count up 1 to the right 2 to locate another point on the line. Then you might want to go another up 1 to the right 2, and let's connect those dots with a line. And we've graphed the equation of a line. Now let's check it using a graphing calculator. What we're going to enter in our calculator, by the way, is 1/2 p minus 1, but we can't use the letter p. The calculator will only accept x's. So parentheses 1 divided by 2, close parentheses, x minus 1 is what we need to enter. Let's take a look at that graph. And it compares very well to the graph we made by hand. Well, let's continue by going the other way. Given an equation, given a graph, let's try to come up with an equation. This graph, let's pick some convenient points. Seems to go through the point 5 on the y-axis and 6 on the x-axis. And if we want to write it in slope-intercept form, we're going to need an A and a B. B is the vertical intercept, which I can see is 5. A is the slope, which I'm going to have to figure out from the graph. What I see is that if I'm at the point on the y-axis and I want to go to the point on the x-axis, I have to go down 5 and to the right 6 units. So the slope is down 5 to the right 6. The equation of the line in slope-intercept form then is negative 5 over 6x plus the vertical intercept of 5. And that's what I was looking for. Well, let's look at an application of some of this information. Suppose that we know a computer costs $1,999 new and decreases in value about $200 each year from the time it is purchased. The first thing we want to do is write a linear equation that will give the value of the computer as a function of the number of years since it was purchased. Well, let's choose some variables. Let's let v be the value of the computer, and let's let t be time in years since it was purchased. We can say then that the value of the computer was originally $1,999, but we'll take away from that $200 for each year since it was purchased, where T represents the number of years since it was purchased, and $200 is the amount in value it loses each year. So there's our function. The first question we want to answer using our function is, what will be the value of the computer 2.5 years after it was purchased? To answer that question, all we need to do is substitute 2.5, let's use 2.5, for t, and find this number. Let's use a calculator to help. On our calculator, we want to find 1,999 minus 200 times 2.5. That number comes out to $1,499. And that's the value of the computer 2.5 years after it was purchased. Well, there's another question I want to answer with this model, and let's look at that now. This question is, how many years will it be until the computer has no value according to this model? Well, our model is V equals 1,999 minus 200t. When it says has no value, we're interested in finding the time when the value is 0. So let's put 0 for V and solve for t. What we might do first is subtract 1,999 from each side to get negative 1,999 equals negative 200t. To solve for t, divide by negative 200. And so t is going to be whatever this division comes out to. Let's do that on a calculator. Let's find negative 1,999 divided by negative 200. And that's 9.995. We should round that to probably around $10. Oh, not $10, I'm sorry, 10 is a time, not a monetary amount. So it's about 10 years at which the computer will have no value. Well, in this lesson we've looked at graphs and equations of lines. Be sure to work lots of exercises from your textbook for practice.